Good afternoon, everyone. Before we begin, please confirm that you can hear me and see the slides clearly by just typing yes in the chat window. Also, we would like you to introduce yourself, your name, designation, company, and the country you are based in. It's a pleasure to see an international audience of people from all industries and backgrounds. Good to see you all, and thanks for confirming. I would like to thank you all for registering and taking time out on a Sunday to learn about case study presentation for vibration, measurement, analysis, and troubleshooting in piping systems. My name is Aisha Khalid, and I will be your introductory speaker for today. It's a pleasure to host this webinar for you. This is our 79th webinar in a series of technical webinars we are conducting. As a practice, we are conducting one webinar every month. Please follow us on LinkedIn and YouTube and make sure to check our website for the latest updates. Today, we have an experienced panel of speakers. I am with my colleague, Mr. Ijazul Karim Rao, Managing Director, Principal Integrity and Safety Consultant, Madam Mubina Khatoon, Director, Engineering Services, and Mr. Anthony James Williams, General Manager, Global Sales. Moving forward, during this webinar, we encourage you to keep asking questions to clear any doubts. We would definitely like your engagement on this topic. You can type your queries in the question and answer window and you will receive a reply in the question and answer window, or we will answer it live. We will try to answer as much questions as possible during this session. As we have a detailed question and answer session at the end, please accept our apologies if your question is not addressed due to high volume of questions we usually receive. We have to be selective. Furthermore, we will also be issuing participation certificates to all those who have attended at least 80% of the webinar and have participated in the discussions through question and answer. Since this is a quite technical subject, we will just touch on key theoretical and practical aspects of case study presentation for vibration measurement, analysis, and troubleshooting in piping systems. In this limited 2 hours, we request you all to follow along with us and keep asking questions to help us make this session as engaging as possible. Before we begin, although most of us are in the comforts of our home, we should be aware of emergency exits. We should keep a safe distance and generally take care of ourselves and those around us. Now, I will hand it over to Mr. Ijazul Karim Rao.
Good day and assalamu alaikum everyone. You know that today is for cricket lovers. It's a final match ongoing between India and Australia, and it's a busy day there. And we already planned to have this webinar. So there is a match between us and the cricket lovers final World Cup match. Anyway, we'll go through with our webinar as planned, and I hope it will be beneficial for the people who would be attending it. And yes, all nations are not involved in cricket like India, Pakistan, England, and Australia. So we'll be focusing on the topic. So today's topic is like introduction to the vibration measurement, analysis, and troubleshooting. Not only like our topic is more focused on basically piping systems, and but we'll be having some like introduction to the technical terms which are being used under this process. What is vibration? Or vibration of piping system may be induced by internal pipe flow behavior, and these flow behaviors can be described as a pulsation, two-phase, and turbulence flows, or it might be caused by external pipe flow such as wind. Such piping vibration is generally termed flow-induced vibration and has a potential, of course, of cause damage of the piping systems. In general, we may say it, vibration can be caused by various aspects, internal, external. It could be also associated with the associated equipment like downstream of compressors, pumps, PSVs, and control valves. What's vibration? Practically, we try to understand that. Vibration is an oscillatory motion about an equilibrium position. Consider a simple mass on a spring and how the spring can move back and forth, and that is called vibration. And there could be to and fro motion, and sometimes high pitch, low pitch. All those aspects are practically applicable. How we define like the oscillation motion. Normally it's called natural frequency, Fn, which is 1 over pi into spring stiffness over mass and then square root, where the definition of this, like how we define normal vibration, it could be a displacement, it could be in terms of velocity or in terms of acceleration. Then common causes of piping vibration, they are defined as flow-induced turbulence, then mechanical excitation, pulsation, high-frequency acoustic excitation, surge, then momentum change due to valve operations, cavitation, and flashing. Then, like how we define flow-induced, the flow-induced could be like at the turbulence. Turbulence is normally defined as like a Reynolds number definition. If flow is having a Reynolds number less than 2000, it's called laminar flow. Between 2000 and 4000 value of Reynolds number is called transition, and then after 4000 is called turbulence. And it's driven by velocity and diameter of the pipe. Yes, the driving, this is always a war between driving force and frictional forces. And frictional forces are the viscosity, which is trying to restrict the flow, and pumping force or the compressor power, which is basically driving the fluid toward the forward direction, and it's causing the fluid to flow. And the ratio of the hydraulic momentum is basically defined by Reynolds number. And then how the turbulence and the noise or these aspects are basically produced. Those are produced mostly at the bends, at structural discontinuity or flow discontinuity positions like elbows, T's, and like orifice plates. There could be a reducer, valves. So these all aspects create turbulence, like a hindrance to the flow, and then hindrance of the flow is causing the turbulence, and the turbulence is causing the vibration, and vibration is causing the basically a problem for the pipe failure or the sports failure. Okay, now most cases we see that turbulence could be, like as I explained earlier, is most on the flow discontinuities, which I described as elbow, T, bends, again the reducers and valves. Typical examples, like I also told as per my presentation, so I covered it. Then there is a mechanical excitation. The mechanical excitation is like all the piping systems are connected with either compressor or the pump. And the downstream of this compressor and pumps, like there could be a various kind of types of these compressor and pumps. Two main types are like centrifugal, and the other one is a positive displacement. In positive displacement, there is a piston movement, or there could be a screw movement. And under these movements, when these equipments are trying to produce the pressure by rotating of their impellers, these are the cause of the sometime pulsation as well, and pulsation is causing the vibration. And these like vibrations are controlled by proper support of the pumps, compressors, as well as the proper sizing and proper supporting of the piping systems, as like straight runs, elbows, and so on, how they should be placed, they are controlled this way. Then there are also dynamic forces which are caused by which are associated with the movement of the basically pump and compressor, and associated with the pipe work. And then there could be a resonance, like if let's say pump and compressor is vibrating or causing high pulsation, then it may have some like a resonance on the piping system. If piping system is not properly supported, anchored, or properly sized, then it may also have a resultant basically high vibration. Now, normally high level of vibration and failures only occur when the pipe work system has a natural frequency at a multiple of the running speed of the machine. This is a normal definition. To ensure that there is no coupling, the excitation frequencies, including harmonic, should not be within 20% plus minus of the structural natural frequencies. Here, how to break this relationship? This is through proper anchoring, proper supporting, and proper sizing. How pulsation works, like if we see that pistons are moving back and forth, right? There's a movement back and forth, and that at some stage it is pushing the fluid forward, sometimes it's coming backward movement. And that pulsation it is basically for the positive displacement piston driven either compressor or a pump. This issue is more connected with that. In centrifugal type, mostly the centrifugal impeller is moving and direction is one way. So there's less chances of pulsation. But if the driver, like a pump and compressor, if they would be as a like a positive displacement piston driven, then pulsation could be the more dominant cause of the vibration. Then there are high frequency acoustic excitation. For example, if a system in a gas system, high level of high frequency acoustic energy can be generated by pressure reducing devices. For example, if you have a PSV, if a PSV is lifted and very high flow goes to the flare side, it can cause vibration. There are control valves, pressure reducing valves, and in those areas also there could be high energy pressure is converted into velocity, and velocity is high in the low pressure zone. In that scenario, there could be high frequency of the vibration and the sound as well. Similarly, there are the flashing point also, which is causing high excitation or high acoustic excitation, we call it. That is from when a steam condensate from a high pressure steam system is if mixed with the medium pressure or low pressure condensate system, then flashing may occur there. And that flashing can also cause high erosion as well as high vibration and noise in the system. Now, if the time to failure is short, typically a few minutes or hours, due to high frequency response as well as giving rise to high tonal noise level external to the pipe in the form of acceleration, can generate severe high frequency vibration in the pipe wall. The vibration takes the form of local pipe wall flexures and in potentially high dynamic stress levels at the circumstantial discontinuities. Like normally, if these like vibrations are high and the noise is on the higher side, and if the frequency goes more than acceptable limit, then there is a potential there could be a failure at the anchor location or at the structural discontinuity like bends and tees. There could be high stress, and this may cause basically a failure. Similarly, high noise is also generated by high velocity fluid, impingement on the pipe wall, turbulence mixing for choked flow, like a shock wave. Like there is also, if it is occurring due to, let's say, if there is a hammering, if there is a outlet is basically blocked, that could also be a case. But impingement is different case. The impingement is the high noise level are generated by high velocity fluid impingement on the pipe wall, turbulence mixing, and for choked flow, shock waves downstream of the flow restriction. They are function of pressure drop across the pressure reducing devices and gas mass flow rate. Typical dominant frequencies associated with high frequency acoustic excitations are between 500 to 2000 hertz. Now, surge momentum change due to valve operation. When we call this surge, a surge is like a pressure wave caused by kinetic energy of a fluid in motion when it is forced to stop or change direction suddenly. For example, if a outlet valve is closed, then there could be a backflow and surge which can impact backward, and it may cause also a sudden failure and a high vibration and high sound as well. Then there are high transient forces can also be generated by a rapid change in fluid momentum caused by the sudden opening or closing of valves, for example, fast opening of relief valves. Like cavitation is another part. Cavitation is a process which normally we refer in the pumps. For example, if a pump NPSH is not being provided by the upstream, like a vessel or the upstream flow incoming, then if a gas is mixed in the fluid, there are bubble and bubble burst all of a sudden. This bubble bursting cause cavitation and noise, and also cause high erosion on the impeller or the piping system. So cavitation is normally it is managed by like proper controls, and like mixing of gas in the liquid when it is being pumped should be avoided. Secondly, NPSH as per the applicable practices is required to be maintained. Like here, if you see that there is a pump impeller piping. No bubble, no issue. Early stage of cavitation, when any bubble comes, that bubble is in the impeller will burst and it will cause supercavitation, right? So this is like a normal phenomena in the pump where we are designing pumps. The proper NPSH is ensured, proper flow of the proper quality of the fluid is also ensured, so as there is no air or any gas mix up with the liquid and causing this cavitation. Flashing. I earlier also mentioned flashing is a more common phenomena in the condensate, especially steam and it's the condensate when it's being separated out by, either by uh, steam traps or some other reasons. Normally, if the high pressure steam condensate is when separated, when it goes to the low pressure area or in the deaerator area, so in that scenario, steam can flash and it can cause high erosion, corrosion, and noise and vibration. So those areas are properly covered by appropriate design. So as sudden pressure changes should be avoided, and so as the flashing of the condensate back to steam could be avoided. And sometimes flashing also is a problem when we have some chemical injections or merging of the like a process streams which are based on various phases. Now, typical like a vibration risks in a piping system, if you try to see, like one of, if you see the picture here, pump, and here mechanical excitation could be a pump, could be a source of mechanical excitation. Then pulsation is on the like when the nozzle is being connected. Then there is a AIV, which could be a change in the direction in the fluid. Then there is also relief load. SBCs means small bore connections, dead leg pulsation is there. Then there is also water hammer could be sometime in the like when it is a surge back coming back to the piping system. There could also be problem of structural transitions, transmissions. Like if pipe is locked with the structure, if structure is also got some like a tendency of vibration, not properly designed or supported, then there could be a resonance and there could be high vibration in the whole system as well. And sometimes there's a need of basically uh, structural like anchor supports, and if the all piping system is supported by the normal guides and supports are flexible to avoid stressing of the overstressing of the piping system due to less flexibility, less number of elbows provided to the piping system, then there could also be a problem in the system. Cavitation could be in the control valves downstream or in the pump side as well. Gentlemen, please keep writing your questions, and as we go down next, there would be a chance we will be giving chance to the audience to ask their questions by voice, and then we'll be answering your questions also. So our plan is to make this webinar more interactive, so as we can talk to our audience and it can be more interactive. So piping fatigue, like due to vibration, like if what kind of issues are caused, why vibration is a concern, like why we need to make sure the vibration levels of the piping system are kept under control. So here there is a one figure which showing fatigue crack shown by dye penetrating test. There is a one crack shown here. There is also weld joint fatigue crack, clear leakage you can see on the side here. So this is like one of the example how the vibration can cause failure and leakages in the system. There's another one. For example, these are the supports where the metal pipe is directly resting on the like a pipe is directly resting on the other metallic part and causing ferreting between the two surfaces. If there's a vibration in this part, this would be causing high corrosion and higher potential of the failure as well. Then this other part where crack may occur if due to fretting and the vibration. But we try to understand, like up to now, what we have understood, what is vibration, what kind of causes are there which can cause high vibration. Number two, if these vibrations are there, what could be the next consequence? Consequence is the high corrosion and failure, right? So it is a serious issue, and we need to maintain proper integrity of the piping system. That's why vibrations are always required to be kept within under control. So next part, piping vibration types. low frequency vibration is one of the type, medium frequency vibration, and broadband frequencies. So less than 100 hertz, then over 300 hertz, then discrete single frequency, high frequency vibrations also there. So these terminologies we need to keep in mind when we will be going to the next stage. Then understanding of the piping vibration types is fundamentally in order to have a better approach for conducting reliable vibration measurements, accurate assessments, and consequently effective solutions. Vibration in a piping system can be classified based on basically vibration frequencies and overall levels. Like here, there could be like the four things which could be overlapping each other: low frequency vibration, broadband frequencies, high frequency vibrations, and discrete single frequency. So these all are sometimes overlapping each other, but we have to see how to manage them, how to keep them under control. Here, when we say that, like when vibration measurements are done, so how we see that what is acceptable, what is not acceptable. Like here, this is one of the diagram, frequency, hertz, and vibration amplitude, mil peak to peak, like this one. If any number with frequency and the vibration like amplitude is within this like a dotted line or below dotted line, it is considered acceptable. And between this red line, which is black line here, and dotted line, this is called area of concern. But however, if the amplitude of the vibration goes more than this number, which is almost 90 hertz mils, then it would be a problematic. But it is also correlated with the frequency. If frequency means like 10 to 100 hertz. So these two things has to be kept in mind. And when we measure the vibration, we need to make sure all piping systems in the plant remain within acceptable range. Another one, like a velocity point of view, this is a inch per second RMS, and it's also linked with the frequency or hertz, at what frequency piping system is moving. And here, this range is acceptable, and then concern, and then the problematic area. So it's a quite simple guidelines that are provided by Energy Institute and other standards, and if we follow them, we can have a proper control on the system. So how we can measure vibration types, how we can have assessment like whether vibration is under control or not under control. Yes, when fluid is flowing through the piping system, there would be certain vibration, there would be certain sound. So we cannot make it without any aspect, there would be a very smooth operation. No, it's a part of the process. There would be some sound, there would be some vibration, but we have to see whether those vibrations are within acceptable limits or. So now the vibration measurement should be performed at most severe vibration conditions, which may require measurement at multiple operation conditions. For main line, take vibration measurement at those locations perceived to have the highest vibration amplitude, for example, mid-span, near valves, elbows, change in diameter, expansions, and orifices. Then for small bore connections, measurement should be performed at the end flange of the cantilever arrangement. Utilize the piping isometric drawing and mark and label the measurement locations. Take data in the vertical and horizontal direction at each measurement location where necessary. Also take measurement in direction along with the pipe axial direction. Ensure that the pipe service temperature does not exceed the transducer allowable temperature range. If we put a transducer on a high temperature line, it could be damaged. Then it is critical to ensure that transducer is firmly secured to piping. Use a magnet where possible, or if necessary, use a glue to obtain a secure mounting. Handheld transducer should never be used for this type of measurement. Normally it is handheld, but the problem is the probe of the transducer should be properly fitted with the piping system. For small bore, just like as we do normal UT gauging, for small bore pipes, we use micro probe. Similarly, we need to use a vibration bearing tool which can have a proper grip on the pipe with respect to its diameter. Here, this diagram where how we can, a locations point of view, where we can have a measurements. So you can see here existing support, the location, point number 3, point number 2, point number 3, 2, 1. These are locations where measurement has been taken. Description is provided. Somewhere the number is in, this is exemplary number. Somewhere 31 mils, 5 mils, and 6 mils, 19 mils, 20 mils. And this way we can record the measured values of the vibration. And if that comes within acceptable range, we don't need to worry. If there's any out of acceptable range, then we need to take the corrective action. What are the types of the vibration measurement tools? So these are the commercially available tools, and we are not like promoting any one particular one, but what Velosi have been using those. So those tools we are basically trying to refer here. Like first one is a Fluke 805 FC vibration meter. It is a handheld. It can be used. And the second one is Bentley Nevada tools, where is vibration and scout series, and these equipments can be used for vibration measurements. Then next part is standards and regulations, like which governs the basically process of vibration measurement, vibration control, and how the vibration related integrity issues can be managed in the piping systems. See, the main standard normally we refer is Energy Institute UK, a guideline for the avoidance of vibration-induced fatigue failure in process pipe work. The second one is like a company standard, and there are also like a standard like APA 571, which is also covering thermal fatigue and vibration fatigue both, and mechanical fatigue is under vibration basically. And APA 581 also covers mechanical fatigue or thermal fatigue. Then API 580 risk-based inspection program. Then design point of view, ASME B31.3, and Saudi Aramco also have a basically guideline for setting acceptable alarm and shutdown vibration limits. So there is also one standard which is Zachem Development Company Maintenance Techniques. This is under ADNOC old standard. Now Zachem Development Company does not name-wise does not exist. Similarly, Takri Refinery also asset integrity and liability manual. They have set the limits, and now Takri Refinery has been renamed as ADNOC Refining. So as we operate in this area, so there are companies like Saudi Aramco, ADNOC, and Energy Institute UK. They have established guidelines for these standards, and we can use them for the reference. Similarly, like API 618, which is reciprocating compressors for petroleum chemical industry, they also set the limits for the vibration controls. Similarly, API 674 positive displacement pump and Shell DEP 3103801.29 general pipe support guideline. And similarly, BS 7608 is a fatigue design and assessment of steel structures, which provides us the guideline for this purpose. Now, before like overview, like we completed the standard like overview, which is Energy Institute guideline for the avoidance of vibration-induced fatigue failure in process work, in process pipe work. Under this standard, if we see it, the title is the guideline for avoidance of vibration-induced fatigue failure in the process pipe work. And then what are the titles or the topics covered under this standard is overview of the piping vibration, like introduction to vibration, common cause of piping vibration, vibration-related issues, then undertaking the proactive assessment, like overview, risk assessment, main steps, then troubleshooting a vibration issue, then technical modules of the various kinds are there. So this standard is very useful if you wish to refer to control piping vibration-related integrity issues. Then this is basically the standard. This document provide a public domain methodology to help minimize the risk of vibration, included fatigue of process piping. It is intended for use of by engineers with no prerequisite knowledge of vibration. However, vibration is only superficially covered by standard design codes, and hence awareness of the problem among plant designers and operators is limited. It is intended that this document address those issues. Then another standard, which is Saudi Aramco guideline for setting acceptance, alarm and shutdown vibrational limits. Here, recommended acceptable vibration level, which is related to the bearing housing seismic vibration. Then recommended workshop acceptable vibration level, Then it also got valve vibration levels, shaft relative displacement, then radial dual voting, and similarly it also got a limit for the piping systems as well, I remember, and we have been referring this code for that particular practice. So the purpose of this document is to lay down guidelines for acceptable alarm and shutdown vibration limit for existing rotating equipment and arrival piping and valve vibration levels throughout Saudi Aramco. This document is not applicable for establishing acceptable criteria for equipment factory test, for commissioning, or for setting alarm and shutdown criteria for monitoring or protection system for new equipment. So we will go to the case study, vibration risk assessment and survey for onshore offshore production assets. We'll be going through, but at this stage we'll take the questions and we'll try to answer those questions one by one. Please raise your hand. Like we can tell the name wise which question. Then the person we can give the chance to read the question because the first time.
For those who have questions, can you raise your hand?
This is a new experiment we are doing first time. Maybe we face some difficulties. We apologize for it. Can you read the question first, then we can ask the guy.
Mr. Abdul Bais, can you unmute yourself?
If Mr. Abdul Bais, if he can ask his question by reading himself.
Hello.
Yes, please. Yeah.
Sir, I just have a doubt on the pump. Can you please tell me what is the design is for a centrifugal pump, considering all parameters the same? We should design for the low density fluid or high density fluid. I had this doubt for been a long time. I just need to clarify.
Right. See, first of all, our topic of the day is the piping vibration, and vibration issues which are related to pumps are a little bit different than piping system. However, when we are selecting the type of the pump, where it is a centrifugal pump, it means, we have to make sure the manufacturer required NPSH is provided, and whatever the fluid density and viscosity and vapor pressure is, accordingly we have to provide the NPSH to the pump. See, if vapor pressure of the pump is low, then it could be more like we need to have a high level in the upside. If the vapor pressure is high, then it may have a better usefulness. So density is not that issue for the pumps, but vapor pressure is more relevant. Okay, go to the next question, please. Thank you.
But I've been told that the low density of fluid requires a high head pump, and we should design for it.
So, yes, you can correlate density with the vapor pressure. Basically, if the vapor pressure is high or low, then accordingly the pump selection and the manufacturer recommendation is required. Normally, when it is a low vapor pressure fluid being handled by the pump, then there is a problem. There is also in the refinery, if there are high flash point pumps, then we need to have double mechanical seal, and we need to make sure there is no oxygen coming in touch. So, like those are the criteria when selecting the pump design with respect to particular manufacturer. Go to the next question, please. Show the question.
Can you unmute yourself?
My name is Shoaib Ahmed, and my question is regarding the piping system, that why the pipes are rested on metallic supports when they are supported on the in piping rack. Can it be rested directly, or the metallic supports below the pipes are needed?
So there are two considerations there. Number one, for insulated pipes, if you try to directly support the insulated pipe on the metallic support, it would be damaged, right? And it means for that purpose, we need to have a shoe under the pipe, so as the insulation of the pipe is not damaged. Number two, when if a pipe is directly resting on the metallic support, right, without extra plate on the pipe, then there could be a metallic fretting kind of corrosion, which I will show the example. And in that scenario, by thermal movement or the vibration related movement of the pipe, there could be a high corrosion at that particular location, which is called normally 6 o'clock related corrosion, and that can be a problem for future after 5 and 10 years, after 10 or 15 years in the offshore areas or wet areas. So that's why it is always advised pipes should not be directly supported to metal, and it should have some resistance in between, or extra plate, or maybe non-metallic part also is placed there, so as metal to metal corrosion potential can be minimized. Okay, sir.
Yes, thank you.
Go to next question,
Thank you,
please.
Mr. Shea, for cooperating. Next one, Mr. Hussam Maki. Can you unmute yourself?
And last question, please.
Raise your hand, please, Mr. Hussam.
Hussam Maki.
Yeah.
I can read the question. As there is typically several causes contributing to the vibration in the piping, as shown in the example, how can we determine the driving causes or the strongest source of vibration in order to troubleshoot the source of issue? See, when we are measuring the vibration, we are at the plant, we will be able to see if whether the associated equipment, upstream equipment like a pump or compressor, is causing the vibration, or that location is at downstream of the control valve, or at a flashing point or pressure reduction station, or it is a vibrating due to absence of proper supporting. So as we go in the field for vibration measurement and site surveys, we will be able to know that. Okay, so it's not like when we are doing the root cause analysis, or we are doing surveys in the field, we will not be able to know the actual cause. We will be able to know the actual cause, and then the required corrective action can be taken. Next question, please.
Mr. Amina Ruch, can you ask your question, please?
Okay, if she's not able to speak, then you can read her question, please.
Her question is, when gas comes from high to low pressure areas, temperature impact?
Yes, it is important. See, when gas is coming from high pressure to low pressure area, there is a Joule-Thomson effect, and it can have a low temperature, and that low temperature we need to properly assess. Like if this temperature should not be lower than MD-MT of that particular piping system. See, MD-MT is minimum design metal temperature, and if the for welded for weld and the base metal, if MD-MT design MD-MT is higher, so let's say higher than the temperature caused, low temperature caused by the pressure reduction in the piping system, it can cause failure. So in this way, you can assume that like the pressure reduction and associated temperatures are very critical to prevent brittle fracture related failures. Next question, please.
Mr. Muhammad Adkan, please ask your question. You can unmute yourself, sir.
So if he's not available, you can read the question. Yes, in pulsation, can dampers in PD pumps are enough for dampening the pulsation? Yes, this is one of the tools which is used for killing the vibration and the pulsation coming from the pressure positive displacement pump. This is one of the solutions, sir. Okay. So the next question, please.
Next, Mr. Farid Almari, can you please raise your hand for your question? So just unmute your mic and speak, please.
Assalamu alaikum. Good morning.
Wa alaikum assalam, sir.
Yes, this is Farid Amari from Algeria, but I am HSE, but in drilling and workover activity. As there is no much piping vibration, only I see that there is piping from mud system to the going to the rig floor that pushes the mud. Always there is this vibration. Can we talk a little bit about this and what precautions need to take care of, or what is the role of HSE in that matter?
See, HSE is not a design department. Your role is to involve technical department to solve these problems, right? And sometimes issues coming from the project stage designing, and some issues are caused by operational mismanagement. So if it is a design related issue, then corrective action is required with reference to adding of new supports, new anchors, locking and putting some like rubber type also material to avoid frictions and so on. But if integrity operating windows are bypassed or the production capacity of the facility is increased, it may also cause some high vibration. But as a HSC, you have to raise those points to the management so as failure could be avoided, and consequently the HSC related incident could be avoided. Thank you. So next question.
So Mr. Ravi Kanian, we have allowed you to speak. Please unmute your mic and.
Hello.
Yes, sir.
Good afternoon.
See,
This is Ravi Kanian.
Ravi, you
Yeah, I'm
can
from India.
read your question and ask.
Yeah. Once we observe the vibration based on the acceptable level from Energy Institute, more than the level, what we have to do the next step?
The next step is, see, maybe there could be a design change required, or
Okay.
you may have to add new supports or anchors, or third one, you may have to take some corrective action with the help of operation. So, because if then level of exceeding limit is also to be known, whether it's a low level, medium level, or high level, then accordingly decision has to be taken by technical department with help of operation. This is normal practice, sir.
Okay.
Thank you.
Thank you, sir.
Next question.
So next question is from Mr. Mukhtar. Mr. Mukhtar, we have allowed you to speak. Please speak. And your question was usually piping connected.
If you are available, please read your question. It's better to hear from the participant. Mr. Mukhtar Muhammad, if you are there.
Thank you very much, sir, for this knowledgeable webinar. My question is especially for the reciprocating pumps piping, there are more vibrations to be considered. So how can we mitigate this vibration? Is there any solution or to reduce the vibrations?
Sir, for the reciprocating equipment, like API 618 and API 674, there are two standards. And if the source equipment will be operated within acceptable limits, then and they will not be the source of excitation to the associated piping, then the subsequent piping vibration can also be controlled. So it's a stage-by-stage control by dampers, by installation of dampers, by having proper supports, or multi-stage pumps rather than making one-stage pressure creation, which may cause high vibration or sound. There could be multi-stage compressor, multi-stage pumps, so pressure is not increased all of a sudden or decreased in some cases when we have a pressure reduction. So these aspects are controlled by proper designing of the overall system. However, if this sound is noticed after, for example, the system was put in operation and for some years system worked in a normal way, and then these problems appeared, and in that scenario we have to see maybe some issues are caused by the maintenance, maybe the overall alignment has been disturbed, or there could be a vibration in the hose or in the bearing, and those parts has to be managed properly. So this has to be seen as a part of like a RCA by the maintenance team or technical team, which caused the extra vibration in the driving equipment, or it was at the original engineering stage or at project stage. So then accordingly corrective decision is required to be taken. Next question.
Thank you. Yes, I got it. Thank you very much.
Thank you.
So next question is from Mrs. Kanthan. Mrs. Kanthan, we have allowed you to speak. Please speak and address your question, please.
Yes, sir. Thank you. Thank you for the. Sorry, I am audible. Sir, am I audible?
Yes. Please go ahead.
Yes, sir. Thank you for conducting this seminar. So it is very useful to understand the piping vibration. So in our plant, we are doing some small bore piping for the reciprocating compressor. We have done, and 2 years ago we have done the SBB survey, and we found something, and we put some supports. So after 1 years, this vibration is occurred, and another before the dampener and after the dampener, it is going through all the lines. So this is indicating something we are not adjusted properly. So what could be the reason for this?
See, if I can recall back, there was one case in one of the compressor in Redknapp Group company. where the lube oil, small piping broken, and it caused the shutdown. And then Velosi was invited to do the study for the similar other systems. So what we did stress analysis and dynamic stress analysis, like whatever the vibration, like supports and vibration hertz could be caused by the machine. We tried to add those numbers, and we could see where were the weak points, and then accordingly supports were added, and that way the problem was solved. So sometimes small bore piping, which is not supported properly, may have a resonance and may fail after some time. And like you said, one example you referred and one example I have seen. But the solution what we applied at that time was doing stress analysis, dynamic stress analysis, not static stress analysis, by using Caesar 2 software, by allocating all the supports and guides which were applied on the piping, and then we were able to find the weak links, and those weak links were basically supported properly afterwards. So that was the solution. And like as such, if we know the cause, then we may have to take corrective action, that I can say.
Okay, sir. Thank you, sir. Another one questions. We are small bore piping. We are considering that below the 2 inches. So above the 2 inches, it is up to 6 inches, 7 to 8 inches are there. So that for in this procedure EA guideline, we are following that. This procedure is applicable for the above 2 inches also.
See, like if I share again one example where when one of the project where even fire water was coming from a jetty to the refinery area, and at the early stage, it is a 10-15 years ago story, and we started the pumping, and but pipe was the fire water line which was supposed to carry the water from jetty was not properly anchored at various locations. The whole pipe rack was vibrating. So the corrective action what we took at that time, then we put the anchor supports and guides wherever it required, and then this problem was solved. So now the lesson learned is whether small bore pipe or big dia pipe, the proper design, then followed by stress analysis study, which is required by ASME B 31.3, section 327 or other relevant sections. So if we follow that, then the Energy Institute is a secondary guideline. The primary guideline is coming from ASME B 31.3, and then the supported standards with reference to the associated equipments, and the Energy Institute also is able to assist and help us.
Okay, sir. Thank you so much, sir.
Thank you, sir. Thank you. So another question, or we can go to
last question. You can take off.
Right.
Mr. Julius, we have given you the permission to speak, and can you unmute yourself?
So I can read this question. Like type of supports. Normally, what we use in the piping system, they are from anchor, guides, and one of the support is also spring type. And spring type supports are used in high temperature variation areas. So, and sometime on the downstream of the compressors and other equipments. So where flexibility is restricted, so we need to bring spring supports, and spring supports, when we bring it, they come with their own problems. So we need to maintain their integrity, number one. Number two, if any rigidity come in the spring, then there could be a problem. So it's a part of like critical piping design, or the most, I would say, the most difficult piping systems in design aspects and future integrity management aspects are coming from the spring hangers or spring supports in the piping systems. So, gentlemen, thank you very much for your questions, and we will continue our case study now. We will go above. Like a case study is a really like what we have done for one offshore, basically a client, and where we have gone offshore platform and their onshore facilities as well, and where practically we have done measurements, proposed solutions, and it helped. And that is the basically lesson learned we are sharing with you today. And there are like various aspects. Please, if you as you go through this presentation, so you can write your questions, and at the end of the session, we will have these question answers again by involving the person who would be asking the question. This we are trying first time, Like previously, we have been doing webinars since last 3-4 years now, from COVID onward. And previously, we were reading the question and we were answering. No, we thought we should involve our participants, like we can have a more interactive, basically, session. So please feel free to write your question relevant to the this case study, and then accordingly we'll try to make it more interactive. Thank you very much for your participation. And this case, like I said, what we have done, this was background was the company has raised the concern of the risk of vibration induced fatigue in process piping within their facilities onshore, offshore and onshore, both it was there. Considering the risk, company has decided to undertake a vibration risk assessment and survey to undertake a risk analysis to identify high-risk system equipments, including physical measurement using a variety of analytical techniques outlined in detailed scope of work, and then permanent mitigation solution to reduce the risk as low as practically possible. The objective is to identify lines subject to the vibration, perform walk-down survey of the plant, perform a vibration risk assessment, and provide recommendation for mitigation. The detailed scope of work: identify the piping, instrument, tubing, and structural elements or ancillary static equipment elements across the production facilities that represent an integrity threat due to vibration-induced fatigue. Then visual site survey as well as a review of the document to identify, if any, potential vibration problem and poor installation and design, plant defects from original design intent. Then observe vibration problem on site, perform vibration risk assessment, preparation of anomaly report, provide recommendation to mitigate a mitigation of vibration threat, development of vibration management strategy. Then, like here, what the piping system, what we covered, CP, SF, onshore 15 piping system, then offshore production assets, 176 piping systems, production asset 2, name has been changed, some data is also changed, so as we don't disclose our information, exact information, so information has been modified for the sake of the security and the secrecy of our client. 120 piping systems. So here, site survey report, this was one of the deliverable, then vibration risk management strategy, vibration risk assessment report, and final presentation containing the various piping with threats due to vibration and their mitigation. So we use basically Fluke 805 for this particular job. Here, this is a technical specification. Vibration tool setup, we did the setup. And then export trend in Excel also it was done. This was the tool what we used. Approach point of view, what we used, like data collection, then data validation, identification of vibration excitation sources, visual assessment, vibration measurement survey, classification of piping as per their criteria defined, result and recommendations, then preparation of anomaly report, preparation of vibration risk assessment report. In the under collection of the information, we collected PFDs, P&IDs, and isometric drawings also. Then equipment and piping information detail as in the well data sheets, heat and mass balance and data sheets. Then selected piping isometrics. Then general knowledge of platform operation, general arrangement drawings, control valve vendor calculations, valve data sheets, line definition table and line list, piping material specification, plant process description and operating manuals. So this was the kind of data what we have gathered, like P&IDs, if you can see 335, process flow diagram 38, heat and material balance of the units, and similarly equipment drawings and so on. So as a register, first of all, we prepared so all required information for identified lines collated for vibration risk analysis from collected documents. All operating design and historical data used for vibration risk assessment was populated in a register template, and it included like basic engineering and operational data and vibration risk assessment as well. So this is the vibration risk assessment, like a piping asset register, the asset type or piping tag number, then equipment type, whether it's pipe or some other equipment, then from to P&ID number, P&ID description, the diameter, piping class, stream number, design code, base material. Then piping schedule, nominal thickness, chlorine allowance, design pressure, design temperature, operating pressure, operating like both units, then operating temperatures, then fluid mass flow rate, both in the oil and the water or the gas. Then identification of the excitation sources. For example, flow-induced turbulence, then flow-induced pulsation, then high-frequency acoustic excitation, mechanical excitation, pulsation, reciprocating excitation, then like a pulsation rotating, like a stall excitation, cavitation and flashing excitation, surge and momentum change excitation, vortex shedding from intrusive elements excitation, and slug flow excitation. So these all were basically identified with the review of the documents. Then here, like in the identification of vibration excitation sources, like if we try to show you. So here on the downstream of the control valves or PSVs, is a control valve, and these are the is a compressor or pump, right? Okay, so these were identified, control valves and the pump and compressors were identified. So in this way, all excitation sources are identified on the P&IDs. Then walkthrough survey of the system, physical examination, the identified piping system to determine the severity of the vibration problem. Note the location where the vibrations are maximum, since these will be proper points to make vibration measurement for use during the survey. Generally, following points are observed which will indicate potential problem: failed piping with fatigue cracks, high visual vibration, line movements, damaged or ineffective supports and restraints, high vibration of connected parts, then high impact flow excited noise, proximity to other potential excitation sources, for example, PSVs, fast acting ESD valves, then general condition of piping, for example, excessive corrosion has significant effect on the fatigue endurance levels, condition of the main line supports also. Then site walkthrough survey, so we have checked that if the line, can the vibration be seen, is the vibration steady or intermittent, is there any noise associated with the vibration, does the vibration increase or certain operation conditions, is there any sign of weeping, leakage or piping branch connections, is there another identical piping layout in the same plant, if yes, is that vibrating also, was there any piping equipment modification on this system, is the piping system is compliance with the applicable standard, then is there any rotating equipment near the vibrating system, if yes, then identify the following rotating equipment type, whether centrifugal or reciprocating, the running condition, pressure, temperature and flow, the vibration level of the rotating equipment also should be checked. Then other, is the vibration due to control valve, if yes, then monitor the valve control behavior like throttling and see if the vibration is associated with it. If there is a check valve in the system, check the following: is the valve creating slamming noise? If yes, is the slamming associated with the piping vibration? Is there any flimsy support like check support, anchor bolt, stud bolt, U-bolt condition? Is there any loose bolt, shared bolt? Then check support contact, is every support in the full? Is there any sliding or rubbing sign on the piping support? Is there a spring support hanger in the system? If yes, then inspect the condition and check the below. Is the load indicator on the working range? Is the travel stop lock is removed? So if you see that, if we follow this, some of the questions which were asked by our colleagues before are answered in the checklist also. So here what we are trying to check, like general information, vibration type, design, rotating equipment, and then we are seeing valves and supports. So if we try to see it, what aspects? Vibration type, then design, rotating related, valve related and supports related. If we follow this, we will be able to find the basically root cause and we can address that. Here, detailed vibration survey was carried out, comprised on review of the line identified over the P&IDs, visual inspection, vibration velocity measurements. Here, due to slug flow, 30-inch trunk line is accessible for to hammering and flow-induced vibration. You can see 30-inch pipe trunk line was having this problem. High noise was observed in the flare line of CPSF. Okay, possibility of operating damage due to the contact of line with the flame arrestor and continuous vibration. This is when pipe is directly supported on the metal. Then physical examination of identified excitation sources to check for high vibration noise, fretting damage, pipe geometry, anchor welded one, supports and clamps and pipe supports damages. Then markup of location where excitation mechanism was evident, identification of damaged pipe supports as well. Now visual inspection findings, what we saw there. Visual inspection confirms inadequate support for pump tubing in upper and lower deck. This could be for pump tubing. It must be for the maybe for lube oils. This could result in vibration-related failure of the piping of concern. Visual inspection confirm inadequate support for such tubing triple pump to triplex pump 2, which is in turn vibrate the concerned piping in high risk zone. This could result in vibration-related failure of the concerned piping. Visual inspection confirmed that no pipe support at the elbow has been installed and other pipe supports are not effective due to air gap and poor installation. This could result in vibration-related failure of the connected piping. Now here, one of the examples where due to structural support, due to vibration or the reason, we could see the cracks appearing in the supports, which is 40-inch flare line damage support. See, flare is normally having very high velocity normal operation because they operate once upon a time, maybe once in a 3 year, 2 year, whenever there is upset at the plant. And due to that upset and the flow load could be very high when full flow is coming to the flare side of the gases, and it may cause high vibration. And we have seen one case at least where flare line fell during the just after pre-commissioning of the plant. So the flare sizing and associated supports are required to be addressed properly. Here, this could be like so outlet to the manifold support damage observed, like practically it may not be ineffective or it may not be controlling. Here, water bath heater damage insulation, if insulation is damaged due to whatever reasons, and there are some vibrations as well. Now, then next part is the vibration velocity measurement. Measurement were taken where vibration was evident and high flow conditions. Time and date was also recorded. Measurement were taken on X, Y, and Z coordinates, and highest value was taken for the assessment. Measurement locations are marked on the PNIDs. Sketches were prepared for line not found on the PNIDs. Vibration velocity and frequency were assessed as per the criteria defined in the institute. The Energy Institute guidelines for vibration induced fatigue and Whale MTH velocity basically procedure. So marked PNIDs where we have taken the measurements. This is like a location SBC1, SBC2, and the various TML condition monitoring locations, so as we could track them properly. So this is like this way we have marked all the 275 PNIDs. It's a big work, but it was done, and this way the measurements were taken. Here, marked asymmetric drawing. Here, if you see it like the same locations, we call TML or CML locations, 1, 2, 3, 4, 10, 8. So these locations we marked on the asymmetric, and then measurements were taken. So all these locations, PNID assigned number, line number, then their facility, velocity measurement, and acceptable, not acceptable. So here we can say refer to anomaly CPF04, refer to anomaly CPF04 again, to problem concern, because here the measurement is 27, RMS mm per second is 10.68, all other were considered acceptable. So this way, these results were recorded for all the suspected piping systems and the flare lines as well. But in general, it should be seen flare in normal operation, flare would be with no load and we will not see any vibration. But flare line will have a vibration when there would be upset condition of the plant. So this could be like a reflection of the normal situation at a normal plant, but flare system normally get problem at the plant upset level, and we need to maintain system to manage the upset or emergency scenario of the facilities. Like here, again, other parts where some like other than flare system, the problematic area where the velocity measurements were taken as 32, 37, 34, along with the frequency hertz also 11, 14, and 12. So you could see that if velocity is lower, frequency is even a little higher, that is acceptable. But if both velocity and frequency are higher, then it goes to the unacceptable range. So this was basically the like criteria of Energy Institute what we used. acceptable, concern, and problem with velocity and the frequency together. So then, like total reading taken 31 in the facilities point of view, and there was acceptable all 17, no issue, no line, basically a number of lines assessed 17, and acceptable 17, and concern 0, problem 0. Whereas offshore production asset 2, 23 with concern, 5 with problem. Whereas the CPSF onshore, 1 concern and 1 problem. Altogether, 24 lines were observed with concern, with corrective action was required, and 6 was observed with a problem. So this was the, if you see, the 85% piping was okay, 12% was with the concern, and 3% was with the problem, and that is the overall. And you can see that, like, if attention is provided this 3% at least, then we can avoid any unexpected problem in the near future. So anomaly report was prepared for the piping tags in concern and problem range. Detail of the anomaly fault and recommendations are presented in anomaly report. Recommendation 1, what was given: design and install of the piping support on the main line of concern. Number 2, a design and installation of 2 plain bolt braces on SBCs. Recommendation 3, reinstate missing support that were originally installed on the piping of concern. Shimming of existing supports, installation of resilient pads liner between pipe clamps and piping, modification or maintenance work on tubing. Here, like one of the recommendation, what is given here is the suction line of CPSF number 3 at vapor recovery unit, where the support, some correction was recommended. And here, like anomaly fault, like this was the recommendation has been given, the anomaly report. For example, if you see anomaly number, then the P and ID number, date assessed, and maximum peak vibration level is 27.13, and domain, like frequency, was 12.12. Mechanical excitation, visual inspection confirm inadequate support for mentioned pipe, and piping is vibrating within problem zone. Increase the support to maintain line by design and installation of suitable supports. According to the need, a resting support, piping guide support, anchor clamps, like tuning could be used. Maintenance activities such as shimming, reinstating missing supports, or those replacement of the damaged support need to be carried out according to the requirements. So then we reach to the conclusion, basically, and conclusion is like summary of anomaly reports, like rerun the hydraulic calculation at current actual flow rate of the to analyze the slugging at finger type slug catcher area. Add, replace the ball valve at PSB bypass line with glow valve to regulate the flow. The recommendation 2 and 3, improve the arrangement of the line to avoid contact with the flame arrestor. Recommendation 2 and 3 were repeated, right? And then offshore assets 1, basically total 31 readings were taken on 17 lines, and as per the given criteria, all the piping tags are in acceptable range. All piping supports should be visually inspected to check the high vibration, noise, creating damaged pipe geometry, anchor supports and clamps, and pipe supports damage after the regular interval. For offshore production asset 2, total 468 readings were taken on 176 lines, and as per the given criteria, 23 piping tubing are in concern and 5 are in the problem range. The total 13 anomaly reports are generated from these tags were immediate recommendations are given for problem piping. Anomaly 13 is combined for all piping tags in the upper deck, which is due to inadequate support for pump section and outlet tubing. Then CPSF, the total 83 readings were taken, and 15 lines as per the given criteria were concerned, and 1 was in problem range. 4 anomaly reports are generated, out of which 1 is for 30-inch trunk line from block 2, 1 for 40-inch player line, and 2 anomalies are for SBC small bore connection. Recommendations are provided in each anomaly report to mitigate the risk damage due to vibration induced fatigue. So this conclude my presentation. I hope it was like some useful information for you, and it will help you to utilize this as a sample to solve your problem, or you can contact us if you need any further assistance from us, any area relevant to your plant. So now last part of the session, if more questions we will try to answer, and then we'll say bye-bye to everyone, because we also need to see India, Australia final match. We are also curious who is playing better, right? So yes, Ms. Adeline, can you start the questions?
Okay, so we have a question here from Mr. Arshad Ali Somolo. We have given you the permission to talk. Can you speak for Mr. Arshad? Can you unmute yourself?
So I can read the question.
Yeah,
Okay.
you already unmuted. Okay.
Am I audible?
Yes, sir.
Yeah, this is Arshad Ali Sumo with you. Thank you for the presentation. I just need to ask you, basically, as we know that in the big main compressor, we need to use the Bentley Nevada vibration monitoring system. So till what extent we need to use this? It is depend on the capacity of the compressor, or does depend upon the power consumption of the compressor?
See, when it comes to the costly machines and equipment, right? So the handheld equipments are not so useful. So you have to go Bentley Nevada or any equivalent system, right? So I don't think there's any shortcut for that. And mostly companies are having Bentley Nevada, what we see in the market. However, for piping related, we use Fluke system. There's a very not costly system, and it can be buy, and you can check that if your piping systems are within the acceptable range. So yes, for machines like compressors, Bentley, Nevada, or equivalent systems, the costly systems are the only option, and you also need to have that information live in the control room along with DCS or PLC. So that is the one of the constraint, and unfortunately, we do not have any cheaper recommendation in mind.
Yeah, basically, I asked this question because I'm facing issue of the delivery time of the Bentley Nevada system. So just need to. That's why I asked the question.
Like handheld equipments are there. You can get any information you want to see by putting a machine, normal probe on the machine or shaft. You can get it. However, if you want to have a proper system, because the machines are critical, so other parties, you can also talk to your manufacturer of the machine or OEM, what alternative solution they may recommend.
We talk to them, but still they are even preferring, even the client is preferring the Bentley Nevada. The issue is the delivery issue is there. So the compressor is delivery time is 8 months, and the Bentley Nevada is coming after 12 months. So
yeah, these are challenges. Right.
Yeah, true.
Okay,
thank you for the answer.
Next question.
Cheers.
Mr. Ahmad Jar, can you unmute yourself? You have given you already the permission. Mr. Ahmad.
Ahmad Yar, yes.
Okay, so I will read the question for him, sir. Sir, I have one question about reducer. How can affected at the pressure in piping system?
See, why reducer is being used? Sometime to reduce the size of the pipe, and sometime to increase the size of the pipe. So if you would be reducing the size of the pipe, then it will you're restricting the pipe size, and velocity would be more. If velocity would be more in the lower dia pipe, then it can have high vibration in the low dia pipe. So as such, the reducer is a component which help to either decrease or increase the pipe size, and it will have an effect on the flow pattern. Okay.
Okay, sir. Next question from Mr. Arsalan Shafat. Mr. Arsalan, we have given you the permission to unmute yourself. Can you speak, Mr. Arsalan?
Yeah, actually, I have one question regarding cavitation. So cavitation means that the bubble in the pipe. So does this cause cavitation corrosion in the pipe, and what is the solution? Another is the question is about fretting corrosion. So how the fretting corrosion is resolved if we want to counter this problem?
Yes. See, cavitation. See, normally if there is a air or some gas entrapped in the liquid, whether it is coming to the pump or it is coming to the, let's say, control valve or pressure reduction stations. So in both locations in the piping system, when bubbles are burst, so they are causing high noise and also causing erosion in that particular area. So the main control on the cavitation kind of damages, whether downstream of the basically pumps or the downstream of the control valve or the pressure reduction stations, to make sure, first of all, that there should be lesser gas involvement in mixing in those areas, especially for the pumps, for the control valves and for the pressure reduction station. If two-phase flow is coming, then there's some problems, right? In that scenario, we need to take care of two-phase flows where two-phase flow can cause some problems of erosion. And then the solution is CRA material to be used in the piping system. So as piping is more subject to erosion, we have seen this problem in the condensate side also, where flashing of the steam is causing that trouble. So about the cavitation is normally controlled by using high CRA material. Issues if you are unable to control the mixing of the gas in the system. This one. Fretting is like a two dissimilar material. If they are resting on a mat, like pipe is resting on a direct on the like piping, let's say channel, sorry, mechanical channel or structural channel, which is steel one. And if the pipe would be vibrating or pipe would have a thermal movement and back and forth. So after some time, when weather is wet, there could be a high corrosion in the surface of the pipe, and pipe is like a wall thickness, and if that goes lower than the acceptable range, then there could be cases of the leakage. So we have seen many fretting cases, leakage cases in offshore environment, and nowadays it is a well established phenomenon. So the no pipe should be directly resting to the metal support. There should be some metal in between, so as this fretting corrosion could be avoided.
Thank you, sir. Thank you very much.
Thank you, sir.
Okay, thank you, sir. Next, we will move forward to Mr. Dak Desai. We have given you permission to speak. Can you unmute yourself?
Hello, Mr. Rao. My question is, what are the vulnerable locations so which can lead to the vibration monitoring location, so which can lead to vibrations? As you have said, this control valve upstream downstream loops with the reducer and the line with the small bore connections. So any other vulnerable locations for selecting the vibration monitoring locations? Can you tell us in punch point you can share?
Yeah. If you go back to my original presentation, where in the beginning we said, I'm going back to my presentation just a minute. See here, if you see here.
Yeah, presentation is visible. Yeah.
Yeah. Now, if you see flow-induced turbulence, mechanical excitation, pulsation, high-frequency acoustic excitation, surge movement chances due to valve operation, cavitation, and flashing, right? So accordingly, the locations would be there. Mechanical excitation goes with the pumps and compressors. Pulsation also with the reciprocating machines downward, right? Then these are acoustic excitation is if the high velocity is coming. Surge, basically it comes to the check valve, near to check valve, but this is a once upon a scenario when downstream outlet would be closed or there would be some sudden closing of the valve. Cavitation mostly in the basically pumps area, and flashing in the steam and condensate area. So in this way, if you go by this, the type of the vibration, which is being main causes, then accordingly, the maintainable item or maintainable locations can be identified.
Yeah, thanks.
Okay, sir. Good, next question.
Thank you, sir.
Any other question, or we can go?
Next question from Mr. Syed Hamid Hussein. Just give us a second, they will give you the permission. Okay, now you have the permission to speak. Can you unmute yourself, sir? Mr. Syed Hamid.
Syed Hamid Hussein.
Okay, I will read the question for you, sir. How to mitigate PSV line vibration due to hampering?
See, PSVs normally, if the undersized, if the PSV would be undersized, and then it can cause some hampering. Otherwise, PSVs are mostly linked with the flare system. And upstream of the PSV is very high pressure. Downstream of the PSV is almost atmospheric pressure or 15 psig pressure. So it will have basically hampering or high noise or vibration in case if the PSV downstream piping is undersized, right? And similarly on the flare system as well, if the flare system is undersized, and at certain situation when abnormal situation is there, and all of a sudden more than capacity fluid is coming to the flare side. So flare and PSV issues are relevant to each other, and these issues are mainly caused by undersizing of the downstream piping and the flare header sizing. So it can only be recovered if there would be proper sizing. The sizes of the downward piping would be provided in the at design stage. There's no easy solution if a flare and the PSV's downward piping is not sized and provided in accordance with our scenario. Thank you.
Next question from Mr. Hasnat Asan. We have given you the permission. Can you please unmute yourself and ask the question?
Thank you, sir, for the presentation. So basically, I have two questions. That what is the importance of valve regulation for the vibration and piping? And second question is how fatal is the flux excitation in the pipe or tubing vibration? Thank you.
Can you repeat your question, please? The sound is lower. First question, can you repeat again?
Sir, what is the importance of valve regulation in the vibration of piping systems?
Okay. Okay, here, first question, this, normal isolation valves, normally we consider them full bore valves. So these valves does not have any issue with the, basically to cause any vibration, because we're talking about full bore valve. But if any valve would be restricting the flow, like a control valve or pressure reduction valve or check valve, in those scenarios, there could be a problem caused by the noise, because if any component of the piping system would be restricting the flow or discontinuing the flow up to a certain extent somehow, so that may have an effect. So like normal, we say that bends from one bend to another bend, there should be minimum so much dia of the pipe length should be provided, so as the flow is not restricted in that way. Secondly, when elbows are there, we say that 5D, 3D, 1.5D should be there in the elbow, so as the flow is not all of a sudden being changing the direction of the flow and causing restriction. Similarly, the valve, when we talk about pressure reduction valves, are more critical, and if pressure reduction is required more than a certain limit, then we also call them multi-stage pressure drop system, right? Rather than dropping the pressure through one valve, you may have to install two valves to drop the pressure at two stages. So this is normal configuration in the valving, but these are the related to control valve. As long as normal gate valve, glow valve, ball valve, which are using for isolation of the flow, those are full bore valves, so do not create any problem in the vibration as such.
Got it, sir. So the other question was, what is how fatal is the slug excitation in the piping and tubing systems?
See, if slug is coming, let's say upstream, this is a problem. If slug would be coming along with the, let's say gas is coming and then there's condensate collected at the low part in the pipeline upstream, if all of a sudden slug will come, it creates problem. And if you got any compressor in the gas side, if slug goes to that compressor, then total disaster. So these things are practically designed at early stage, at feed stage. Otherwise, you will not be able to operate gas compressors with peace of mind if you will have a threat of slug coming along with the gas anytime in the, and the knockout drums which are installed at upstream of the compressor should be of that particular size, or there should be proper safety protections at high level trip, and so as compressor is not basically operating under any threat where liquid can be entrapped in the suction side of the compressor and compressor is damaged. So these are the normal design cautions, and it's a very, very dangerous scenario if we carry the risk of slug being carried to the compressor section. Okay, sir?
Got it, sir. Thank you.
Thank you. Any other question, or we can?
Can you still accommodate more questions?
Yes, no problem.
Question from Mr. Osama Jabbar. Mr. Osama, we have given you the permission to speak. Can you unmute yourself, sir? Mr. Osama. Okay, so his question. Like in railway lines, it expands or contracts in hot or cold, whatever respectively. If pipes also do, if they do, what will be the solution?
See, the thermal expansion phenomena is applicable on every linear component, whether it's a pipe, steel structure, or railway tracks. So the similar phenomena is applied on the piping design, like flexibility analysis of the pipe, always taking care of the thermal expansion related constraints of the piping system, and flexibility is provided. And it is a normal saying, we never lock a vertical section of a pipe between two anchors. It is always expansion flexibility is provided to one side of the pipe. Similarly, if you see horizontal vessels, so there are saddle supports. From one saddle, the vessel is fully locked, but other side, vessel is able to basically expand or contract. So all metallic or non-metallic even components are subject to some thermal expansion due to temperature variation, and design and constructions are done to accommodate that expansion criteria or contraction criteria, which is applicable in the temperature variation scenarios. So,
Next, sir.
yeah.
Okay, sir. Mr. Muhammad Ahidul, we have given you the permission to speak. Can you unmute yourself, sir?
So you can read the question.
Okay, sir. His question is, what is the best support for pipes?
See, if there's no best support, the supports are all types. There could be a resting support, there could be anchor support, there could be spring hanger. So supports are provided as per the needs of the piping system where it is being installed. So there is no best or worst support. Supports are supports, and we need it to maintain the integrity of the piping system. Yeah, next question. Yes, sir, Saleh, then we can close maybe, right?
Okay, sir. Mr. Yasir Salah, we have given you the permission. Can you please unmute yourself and ask your question? Okay, I will read the question in behalf of Mr. Yasir. Do you need to do vibration survey or depend on the issue too?
See, surveys are done if you are like visual survey, visual inspections are done for the piping systems. And if you see some vibration, some issues, then you have to carry out measurement of the vibrations if these vibrations are within acceptable range or not in acceptable range, right? And it's a part of normal life, because we have to have some sort of inspection for the system, for the piping, for equipment, for instrument, for all assets what we have on the facility. We have to have some normal inspection program, and under normal inspection program, the requirement of the vibration surveys would also be a need if we see some problems which are causing or which are appearing on the piping systems as well. So we try to answer most of the questions. If there are more questions, you can send us by email also, and we'll try to answer. And thank you very much for your attendance and sparing this time on the cricket final day. And have a nice day, and we look forward to meeting you during our next webinar. Thank you very much, and have a nice day.